Good afternoon, ladies and gentlemen. It's my great honor to be invited as a speaker for today's forums. My talk, the title is AI-induced opportunity for development of autonomous driving industry in Taiwan. My name is Li Chen-Fu. I'm from National Taiwan University. And this is the outline of my today's talk. On the top, you can see that this is the AlphaGo. Everybody remember that the year 2016 March, the world chess player Mr. Lee from Korea was beaten by the AI programs 4 times out of 5. Since then, application of deep learning and big data together has exhibited excellent solution to complex tasks. For example, image analysis or point cloud data processing, and so on and so forth. Developing autonomous driving system, abbreviated ADS, has become active in Taiwan since 2017. And later in that years, ARTC, that is Automotive Research and Testing Center, has demonstrated its first prototype of autonomous vehicles. Since Unmanned Vehicles Technology Innovative Experimentation Act was formally announced in the year 2018, which opens a sandbox for AV companies for legal semi-field test. Totally 8 local companies have already registered so far. Generally speaking, there are 5 applications that AI can impact auto markets. The first is AI used for helping drivings. 2 major types is to assist the drivers that result in the ADAS systems. Another is driverless automobiles, and that result in the today's talk, the autonomous vehicles. The second is AI cloud services. And examples are predictive maintenance and individualized marketing. Third is AI automotive insurance. That is, the systems can help to assess the driver's driving risk. And second is the drivers can try to file the insurance claim by himself or by herself. The fourth is to apply the AI in the car manufacturing. The fifth is the driver monitoring. Let me show brief videos to demonstrate the driver monitoring.
Hello, Tom.
Hello.
Here are some nearby businesses that may interest you.
So the forecast of the autonomous vehicle market on the left top ones, it shows that the is a market, autonomous vehicles market in North America from year 2020 to 2030s. So it started about 3,000 vehicles in the year 2020, will keep growing, and on the right you can show that the tendencies is about the exponential. And this, numerically, you can show on the right lower ones the market, global autonomous vehicles market in the year 2021 is about $10 billion US dollars, but grow to the year 2030s. The market will grow to the size about 326 billions, so about 32 times higher, and the CAGR is about 47. So it shows that the autonomous vehicles are the futures. And this is the Society of Automotive Engineers, abbreviated as SAE, has defined 6 levels of driving automations, ranging from level 0s, that is fully manuals, to level 5, fully autonomous. So you can see that to achieve the higher levels, the more and more AI techniques will be required. And this is the current, ongoing test on autonomous vehicles at the various levels in the world. So you can see various countries from China, Japan, Canada, France, USA, England, Sweden, Italy, Germany, Australia. They have various kind of tests, even up to level 5. For the autonomous vehicles, this market is quite booming. In recent years, autonomous vehicles are already in the commercial use, and people have heard about a lot, especially from the Tesla. Okay, so many companies are investing further in developing highly and fully automated vehicles. In the figures here, you can show there's huge number of companies get involved in these communities. From vertically, from lower to top, shows the level of integrations. So the lowest is the more about the development tools. In the middle is about the processes, sensors, connectivities, mapping, algorithms, securities. But on the top, it will be more like autonomous full solutions. Okay, so this is a huge communities. And this is the pipeline the illustrations of the autonomous vehicles. It goes from the sense to the final actuate. The sense involves various sensors trying to gather environment information from multiple sensors to perceive. Perceive means trying to understand after the processing and integrating the sensor data. Okay, so the environment trying to understand how many vehicles or pedestrians or the cyclists are around the host vehicles. And go further is safely choose the actions, that is making these decisions. Okay, and finally, this vehicles will trying to execute the orders coming from the decisions. But it's generally it's really hard to understand the complicated the real world informations by rule-based methods. So that's why deep learning approaches in AI rises. And why the AI techniques develops rapidly with AI? This is because with the help of fast development in AI, multiple sensor data can be processed more effectively for surrounding understanding and the following decision strategy making. So in these figures, you can show that 3 circles around are about the sensors. That means the sensors are crucially important for the vehicle to understand the whole surroundings. The sensors covers like radars, lidars, cameras. Okay, and the last circle is about the planning the behaviors and or making decisions and make it act. And there are various AI techniques that have been developed and under the full progress. I will just mention a few in today's short talk. Okay, the first one is about the computer vision. As I mentioned earlier, that the AI has been demonstrated the power in processing the images. Okay, and so the computer vision has been advanced tremendously in these years. And so here in this slide, you can show that the computer vision is a kind of technology acquire, process, analyze, make computer understand the images and videos of the real world. Okay, so in the recent researches, deep learning methods in AI have been used to learn multiple levels of representations in computer vision tasks. And on this right, this is a typical architecture based on the neural networks, especially the multi-layers neural networks involving the convolutions and trying to do the predictions, classifications, or segmentations. And these are some examples using the deep learning on the computer visions. Several tasks, for example, like object detections. So you can see that this is a street scene with a number of vehicles. So this is on the left, this is the 3D bounding boxes trying to identify where the vehicles are and where they are located. Okay, and on the right, this is they are trying to segment the scenes, trying to find where are the potential obstacles, where are the possible drivable areas, so that the vehicles can plan their routes. And so given this visions using the deep learning, very important technique called so-called convolution neural net has been introduced and heavily used. In this convolution neural net is about this how to process the images layer by layer using the kernels ideas. That is, the kernel will try to reform the images layer by layer and trying to extract more abstract data. And finally, we'll come up with a high-level features. And these high-level features will have important physical meanings and eventually will be used to do the final predictions about where whether the object is a car or the object is pedestrians or the motorcycle or the bicycles. But not only visions is used for the object detections. That's about the image-based methods. Besides the image-based methods, there are other sensors used for detections the objects. Because the image sensors have some limitations, especially in the about the lightings. If during the nighttime or during the environments with not enough light, the images usually will be at stake. So other sensors will be replaced. And one important sensor is called LiDAR. So LiDAR-based methods recently become more and more popular, used to detect the objects. Basically, the LiDAR-based methods trying to use the grids, row points representation to detect the 3D objects. Okay, so they are very powerful, and they can be used during the night or during the very adverse environments, especially that lighting is not enough. Of course, these two kind of sensors can be fused to come up with the multiple sensors fusion-based methods. Okay, and this is our current lab is doing. Okay, trying to fuse the image sensors and the LiDAR sensors and even the radar sensors together to come up with the more solid predictions. And this is one of the work we are doing, that is trying to use two stream of the architectures. One is trying to leverage the strengths of the image. One is trying to leverage the strengths of the LiDAR. And eventually we're trying to fuse them together to come up with the final prediction results. But as we all know that this type of AI approaches heavily relies on the data, okay, because the nature is a supervised learning. Although there are a different type of learning, but the supervised learning is usually dominant. Given this supervised learning nature, we heavily or we crucially relies on the clean and fine data. So trying to collect the good data is a very important step, and probably even the first step before this approach can be effective. So as you can see from these figures, we need to collect the data for the LiDAR sensors. We need to collect the data for the RGB sensors. And finally, we can use these data to train our models and come up with good predictions. And of course, besides the understanding of the environments, making the decisions so that the automobiles knows how to navigate itself properly. So autopilot will be also crucial.
It's always looking in all directions. The lasers are what lets it spot a small moving object that's approaching towards the car and estimate its position and velocity very precisely. So this is a very interesting case where there's actually a couple with a dog. At the same time, a jogger is just passing by, and the jogger swings around the dog out of the bike lane into the road. The car doesn't just understand where the agents are. It actually understands how they're going to interact in the near future and is able to make those predictions in the blink of an eye before you can really understand exactly what's going on. This is night construction, which, as a human driver, is one of the more stressful things. The car handles it really, really, really well because the car sees as well at night as it does during the day. For the lasers and for the radars, they see where the cones are, where that aisle of traffic that's being laid out here by the construction zone is going. Red lights and green lights, they're really important, but people sometimes don't obey that. In a case like this, where the red light runner happened, the car is actually checking all around in all directions all at once. And so it can see when there's somebody coming who looks like, wait, they're not really slowing down for their red light. And at some point we decide, wait, they actually look like they're going to run the red light. Let's stop and let them go through. And then after they've gone, on we go. So the thing that's amazing about this one is that you can't see in dust storms like these. There's actually a pedestrian out there that the car sees perfectly well in advance. They're just walking across the road. The car sees it using its lasers and radars and starts slowing down before you as a human even understand what's happening.
Okay, so let's come to this, what's the situation, current situations in Taiwan, the autonomous vehicles. Okay, as a matter of fact, we have quite rich activities in involving or getting engaged in this developments of autonomous vehicles recently. So let me show this short videos to demonstrate this is the autonomous vehicle developed by the ITRI.
台湾智慧汽车的新里程碑，工研院跟新竹市政府合作推动的自驾车今天上路。不同于以往过去只能在封闭空间测试使用，这是第一次有自驾车呢在一般的道路跑。而这样的系统可以用在轿车或是货车等等系统。看来呀，像科幻电影当中的自驾车满街跑的时代，可能即将来临。
我按下我们的按钮，启动自动驾驶。
从这一刻起，轿车就变成了自动控制。但是道路上状况这么多，该怎么应变？团队要来一一说明。就算路边有人违停也没有关系，但要是出现闯红灯的三宝，车子也会放慢速度。但若是遇到有人心急想超车，自动驾驶也会侦测反应。这款由工研院与新竹市政府合作推动的自驾车系统，上午正式在新竹南寮渔港上路。不同于过去只能在封闭的空间测试和使用，这可是全台第一次有自驾车在一般道路上行驶。
Okay, I'm sorry. This is made by a local news, so it's in Chinese. Okay, but from the video you can see that this is the real automotive vehicles. First one that can be run on the open field.
全台第一张可营运自驾车，由去年6月才进驻桃园虎头山创新园区的秦威国际公司率先拿到，今年3月就会在彰化鹿港天后宫与彰滨观光工厂之间运行。交通部长林佳龙表示，这是重要里程碑，自驾车在未来5G 时代将成为引领智慧交通的火车头。
全台第一张可营运自驾车目前在桃园虎头山创新园区公开亮相。自驾车车外有感测器搜集周围环境后，传输至车内的自驾系统处理，再依当下状况做出加速、减速、刹车、转向等动作。内装舒适空间可容纳15人。今年3月将在彰化鹿港天后宫与彰滨观光工厂之间接驳。
很棒啊，嘿啊，很安全又舒适，嘿啊，基本环境设置好了以后，这个行人或车辆或其他的这个障碍物，突然跑出来都能够智慧辨识。
Early this year, the Taiwan autonomous vehicle industry, they have established their alliance. These are the 6 local bus leagues. They signed an MOU to establish this alliance. Okay, and this is the bus have been tried in the Taipei city. Okay, and this is another bus tried in the another city in Zhanghua. Okay, but of course there are various challenges remain. Okay, and this is the videos made by a company called Zoox, showing that if they are in the real environments, they are full of people, populated with peoples and different vehicles. And for the autonomous vehicle be able to do the navigations, it will be still a challenging, very challenging task. And that requires us to develop more AI techniques in order to handle these problems in the futures. So finally, let me make a conclusion. That is, effective methods aiming to perceive and understand complicated road scenes are commercially being proposed, continuously being proposed in the AI field. And projects like self-driving buses in Taipei and Zhanghua demonstrate the potential of combining autonomous vehicles and public transportations. And most of the deep learning approaches relies on large data sets, which give Taiwan an opportunity to develop localized AIs, whereby the flourishing domestic AV industry will lead to a prosperous market in Taiwan. Thanks.